preparing for the data tsunami. Many of us have heard this term. What this really means is that utilities are not normally used to seeing that amount of information come from the field into their backend systems, and be able to process and store and manage this information on a regular basis is a challenge. For example, each residential smart meter records about 2 channels with 1-hour intervals, and commercial and industrial smart meters can record up to 3 or more, depending on your requirements, with 15-minute intervals. In addition, there will be events from the meter, the network interface card installed on the meter, and the network itself that need to be processed. The amount of information can be in several gigabytes, and you're sending all this information on a daily basis to the utility. So it is essential to understand the types of this information being returned and to create a subset of the data that you might be interested in based on your business goal and business value. Take into account use cases that you'll be implementing in the future and what type of data will be required fulfilling those use cases, not just the ones that you're currently aware of. And this is where using industry best practices and information from what the other utilities may have done would be very, very useful. As an example, out of the approximately 1,247 events, we identified approximately 25 that would be most useful for us at this point of time. But having to go through those events was important for us to get to that conclusion. Developing a smart grid data architecture that supports your long-term view of being able to store and summarize data and to be able to take real-time decisions based on situations such as theft and tamper situations, or take operational decisions such as proactive maintenance of distribution transformers, or using voltage information to make switching decisions on capacitor banks and regulators in the field, or to use that information for business insights for being able to better serve your customers by offering targeted DR programs, for instance, are all key things that we should not lose sight of when we start this project. And it's very expensive for us to go back and make changes to the way information is moved around if you don't take into account these requirements up front and develop a data architecture that meets that requirement. As an example, planning to move a superset of the information from key business systems to the warehouse is a stepping stone into that goal and to be able to create that data architecture. That is what we're doing. And in BG&E, what we've done is we have used a combination of business intelligence products along with our own understanding of what analytics and metrics are required for us to fulfill measuring of performance, financial, and operational goals, and taking an incremental approach to developing a warehouse that is used as not only a reporting source for reporting information, but also for deriving those analytics and metrics that we just talked about. We are using an incremental approach versus a big bang approach so that we can build upon it as our requirements are realized, but it's a long-term view with a flexible architecture that we keep building upon versus trying to piecemeal it out. So that approach has basically helped keep the cost down while fulfilling the requirements on a per release basis as you move forward in a 3-year program.
Okay, we saved the best for last, project management. If you can't tell, I'm the business side, Shanu is our IT architect. But I think some key points for us to close this webinar really for project management, it's very important to build in distinct phases for your testing with no overlap. We learned the hard way that we need to space out testing and give dedicated chunks of time to each type of testing. So I can't really stress it enough, but we have system integration, user acceptance, operational readiness, user acceptance testing, regression testing. All of that testing should be kind of well thought out and planned out ahead of time so you've baked it into your schedule. Always need to plan for new and missed requirements along the way. So despite your best efforts at requirements gathering up front, no matter how long it takes and how many stakeholders you involve, inevitably throughout the design process you will discover missed requirements or new requirements that you're going to have to build into the project. And so you need to plan schedule-wise and budget-wise for that, to have contingency for those kinds of proofs of concept, different trials that you want to run, new technologies come out, so and even just plain old missed design requirements. So build that into the schedule. Customer obstructions we talked about earlier, but I think I would just make the point that we have to be very careful about how we deal with those, because those could be typically good customers that always pay their bill on time, but now we have to have access to that meter. So how far do you take it to be able to get access to that meter, and how do we work with them? What communications are required? Who's going to do the work? Who's going to pay for it? At BGE, we've made all those decisions, and we'd be happy to share the details with you offline. And then I mentioned on the first slide that this program is an 8-release program, so 8 distinct projects, 8 PMs, 8 teams, overlapping resources all over the place. And we had to be very deliberate about utilizing those resources, not maxing them out or overusing them, and really for our sake making sure they're available from release to release to support the effort. The last point on this slide, and I'd like to make one final one, though, is the metrics work. Decide early what you want to measure. And then for us, we, long story short, we started with one person designing the metrics for success, and we ended up with a full team of 3 or 4 people, plus this external working group with PEPCO and the AARP and PSC. So internal, external metrics, PSC metrics, DOE metrics, leadership metrics, all kinds of metrics. Let's be clear about what we want to measure, how we're going to measure it, and how we operationalize collecting that information. The next slide is our last slide. Probably our biggest practical lesson learned is that we learn a lot from other utilities. So right from the very start, our business architect role is designed to create and develop those peer relationships so that when we have a question about customer obstructions or data warehousing, we can reach out quickly to a handful of other utilities who are using the same vendors as we are and ask those questions and get good industry kind of lessons learned. They may or may not be a best practice, but it's out there, and it gives you some good feedback, good data to bring back into the company to evaluate and then make decisions on.
We've got time for a couple more questions, and Alice asked if you have experience with segmentation and sending custom messages to different segments of your customer base.
Well, that's a good question. I wish our communications team was here to answer that for you. And what I probably would do is if you can contact us offline after the webinar, I'd be happy to put you in touch with that team. That plan that I mentioned that just got approved by our Public Service Commission, it's a couple hundred pages long, and it includes all of that kind of segmentation data and really targeted communications per segment based on all kinds of data they've collected internally and from external organizations to make sure we're getting the right messages to the right people. So the answer is yes, but for the details, I'd like to put you in touch with someone who knows more about it.
Terrific, and I'm sure those of you are all seeing our contact information here on this final slide if you choose to use it. Mark asks, what is the plan for meters that cannot connect to the mesh?
So for those meters, what we're doing is we are working with the firmware vendors to make sure that those meters are able to record interval reads in the absence of mesh connectivity. And even though we don't have any battery backup on those meters, as long as there's electricity supply in those meters, we will still be able to measure the data. And when the network information and the network is available and the time information is available on the network, they will automatically be able to apply the appropriate buckets to the time that they've recorded without availability of mesh connectivity. Those meters, when the mesh is available, as you know, would be able to communicate back the readings that they've taken in the absence of mesh connectivity, but while they were still on. The second point is around the gas IMUs. Those meters will obviously be on battery power. They will not be on electrical power, and so the outage situation impacts them less. Their impact from a mesh connection perspective is if they're not able to get access to a constantly powered device to be able to send their reads to, they will keep trying on a daily basis. So if they don't get connectivity the first day, the gas IMUs wake up again at midnight the next day and send that information to the constantly powered device, which can be an access point, a relay, or a meter. So we are trying to make sure that meters are able to record data even without mesh connection and information available. And secondly, when mesh connectivity is available, they're able to send all the data they've recorded in a consistent and in a reliable manner back to the utility.
And if I could just add on to that, for billing purposes, we are not going to bill from the AMI meters for the first 5 months of our deployment. So we will maintain walking routes while we analyze some of that data that's coming in. And then as part of our billing release, which is another one of the 8 releases I mentioned, we have a certification process that we developed with the business to say what kind of reliability do we need to see as a business before we're confident in those reads and in the data flow to be able to bill from it. So we have a couple of things. We're going to analyze for a few months just to look at the data coming across before we even attempt to bill. Once we move into that release, we'll certify those meters in batches before we bill from them. And then also, I mentioned briefly the proof of concept that we're looking at for a mobile access point. If we flip a meter to bill from it and then later cannot get billing data from it, one of the things we're trying to test out is a mobile access point, which means we would literally drive by with an AP and try to collect the billing data for that purpose. So there's a couple of good ways to deal with isolated meters. And Shanu mentioned in the beginning we reserve approximately 10% of our relays in the network so that we can optimize segments post-deployment and get a better data flow rate across those segments.
Right, and that optimization applies at least 2 to 3, maybe more network paths from the meter back to the utility. So we always have backup in case one path is down.
Well, thank you. We have passed our time, so we're going to have to wrap up now. Here is our contact information. A great session. Thank you so much, Jessica, and thank you, Shanu.
Thanks, guys.
Thank you very much. We're glad you were here and hope to see you again real soon here at our next Lessons from the Real World webinar. Thanks, everyone.